In our last video, we're going to jump into 3 dimensions and we're going to talk about volume and surface area of different figures. So starting out with the definition of each, the volume, which is denoted with a V, is a measure of the capacity of a 3D figure. So it's how much space it's taking up. So if you think back, perimeter was 1 dimension. It's the distance you're traveling around. That was just units. Area is the space that a 2-dimensional figure occupied, so it was units squared. So the second we bump into 3D, this volume is going to be units cubed. Okay. Now, unique to something that is a 3-dimensional object, it also has a 2-dimensional thing that we can calculate. So that is our surface area. So surface area, to denote that it's different than just regular area, is abbreviated by its initials, SA. What you do here is you find the area of every single surface and then add them together. So just to give you an example, we've got some of the pictures below. But basically what I would do is I would find the area of this 2-dimensional piece, which is a box or a rectangle. Then I would go ahead and find the area of this one, the area of the front, then I've got the back, the left side, the bottom. All of those sides have areas and we add them together. So this measure is for something that's 3D, but it's a 2-dimensional measure. So the units on this are the same as the units for area. It's units squared, okay? So we're gonna go through a bunch of different specific shapes. We'll talk about what's the volume and then also what is the surface area for this. So for convenience, I have them all drawn out because it would take me way too long to have to sit here and draw these by hand. So we're gonna start with a rectangular solid, AKA a box. And so there are 3 measures, but the main idea is for this rectangular solid, this bottom here is our typical rectangle. So we know our rectangle has a length and it has a width. So to put it into that 3rd dimension, it has a height as well. So the box is the easiest volume. It is length times width times height. And I'm going to write this a very specific way because there's actually a nice way to kind of remember a lot of these different formulas. If you think about the base shape here, which is a rectangle of LW, all this formula can be broken down by this is the area of the base shape multiplied by the height. And nearly all of our formulas are going to follow that same criteria. The only difference is when we have kind of sharp points. So you'll see something else comes into play there. Now, when we talk about the surface area, that formula is a little bit messier. So these are something that I typically don't expect you to remember either. But you really kind of break it down just like perimeter. If you remember all the different area shapes, you're just adding them up. So if you think here, if I start with the bottom shape, it's a rectangle. Its area is length times width. Well, that bottom is exactly the same as the top of my box. So I really have 2 sides with area length times width. So that's the top and the bottom. Then if I move on, if I go to the sides of my box, that would be these 2 shapes here. And both of them are rectangles with area W times H. And then I have the front and the back of the box. So here's the front of my box. The bottom is L, and this side here is really also H. And that's exactly the same as the back of the box. So I have 2 sides with area LH. Okay. Then moving on, we've got the cube, which is really just like a dice. Every single side is the same length. So in this case, this bottom shape here is square, and the height is going to be exactly the same. So I'm going to call these sides S, and then the height is the same here. So the volume formula is really just simple. You take that side and cube it, but again, it follows that same pattern. The area of the base is S times S, so it's S squared. And then we times it by the height, which is S. So this fits the same formula. It's the area of the base multiplied by the height. But really, it just condenses nicely. This volume is just that side cubed. When we move on to the surface area, every single side is exactly the same, and they are all squares. So each side has area S squared, and you have 6 sides to a cube. So my surface area is really 6 sides with area S squared. Moving on to a cylinder, aka basically just a can, there's a couple things that define this. So in this case, my base is going to be a circle, and that's exactly the same thing as the top. So there are really only 2 measurements that determine what a cylinder is. You still need the radius of the circle, and it's the same radius up here. And then I need the height of my can. So when we go to find the volume of this, using the same idea, the area of the base is a circle, so that area is pi r squared. And then I multiply it by the height. So my volume is pi r squared h. So same exact pattern. Area of the base multiplied by the height. Surface area is a little bit weirder here, but it's not too terrible. So I'm going to start with the easier components, which are going to be the top and bottom of this can. So each of those is a circle. So the area of those circles are pi r squared. And really you have 2 to represent the top and the bottom. So I'm going to kind of make that distinction here. This is the top and bottom of the can. But what I need to also come up with is what is the area around this can? And so really, it actually comes out nicely. You can do a nice visual with just a piece of paper. But the idea is if you cut this can here, which has a side length height, and then you unroll it, what you end up with is actually a rectangle. So if you take a piece of paper and you roll it up, you're going to see you form that cylinder shape. It's just missing the top and bottom. So this forms the side. So this distance here is exactly where we made that slice along the can. So this is the height. What I need is this long side, but really that's what wraps around the top and the bottom. So that side length is actually the circumference of the circle. So this side here would be 2 pi r. And so it forms that rectangle. The area of this is then 2 pi r times h. So this gives us the area of the side here. There's just a single side. Okay. Moving on to the sphere, this one doesn't fit the same kind of convention. Sphere is the 3D form of a circle, so again, you really just need a radius to describe this. But the way you define a sphere is it's got a center point, and you pick all the points that are equidistant to that center, and it doesn't matter the direction. So the volume for this, unfortunately, I don't have a nice explanation without getting into calculus, really. The volume is going to be 4/3 pi, and then you need to get units cubed, so it's radius cubed. And then likewise, I don't have a nice way to tell you what the surface area is, but it ends up being 4 pi, and then it's an area, so you get your radius squared. Okay. Our last one is the cone. And so in this case, it's just like an ice cream cone. You really have one base here, and instead it comes to a very sharp point. So I still need the radius of that cone, and then I also need the height, which is the distance from that circle to the point, okay? Really, this formula is going to come just from the cylinder formula. Because if you think, if it didn't come to a sharp point, you'd have these straight lines coming down, and then you'd have a circular bottom. What ends up happening is you take the formula for the area of a cylinder, but you're missing these two components. So you really only have one out of three parts of the cylinder. So my volume formula is again the same as the cylinder, which is pi r squared times h. This piece is still the area of the base. This piece is still the height. But now to compensate for the fact that we don't have that full cylinder, we really have 1/3 of it, okay? So this comes from the fact that this is the cylinder chopped into 3 pieces. And we'll talk about pyramids very soon too, and it's the same idea. When it comes to that sharp point, you're missing 2 out of the 3 parts of it. So again, just to visualize here, here's my cylinder. You're missing this side and this side. You just have the middle third. Now my surface area formula for this is absolutely disgusting. Again, this is definitely not something you need to memorize. You will be given this formula if you need it on a test, but on your homework, just have this sheet out with you. So my surface area is pi r squared, which gives me the top of the cone. The problem is figuring out the area that wraps the sides. That's much more difficult. So that ends up being pi times r times the square root of r squared plus h squared. So you can see, not a pretty number in any way, shape, or form, or pretty formula at all. So definitely do not spend time memorizing that. Really, most of the surface areas are not something you need to know off the top of your head. The cubes and the solids, the rectangular solids, those are relatively easy to remember. Same thing, cylinder, a little bit harder, but it's not too bad. But you will see what you're going to be given to you on test in some announcements. So let's try some examples of this before we talk about other 3-dimensional figures. We're going to find both the volume and surface area of the figure. And so we're going to start here with a cylinder. So just to refresh on our volume formula, it's the area of the base, which is a circle. So that area is pi r squared. And then we times it by the height. So in this case, our radius is going to equal 6 inches, and our height is 24. So our volume of this figure is pi times my radius squared times my height. So multiplying this out, this will give me pi times 36 times 24. And then if you do 36 times 24, we usually like to put that at the front, followed by pi. So the exact area would be 864 pi. And then the units on this, because it's a volume, are we take that unit and we cube it. Okay? So this is the exact area. It doesn't say to round, so that would mean I want to leave it in this form. If it does say to round, it will tell you to how many decimal places. So in that case, you would use the pi button. I'll go ahead and round to 2, but if you plug this into your calculator, this is about 2,714.34 inches cubed. So this is the approximate volume. Next up then is the surface area. So again, you can have that formula out for you, but we've got two circles that make up the top and bottom. So we're going to go ahead and find the area of both of those. So the area of a circle is pi r squared, and we have 2. And then we need the side of the cylinder. So again, if you cut this, that forms that side, and then this part completely wraps around the circle. So that would be the circumference times the height. So it's 2 pi r times h. So this is the top and bottom, just going to abbreviate that. And then this is the side of that cylinder. So filling in all those pieces, our surface area is 2 pi. The radius is 6, so we square it. Then we've got 2 pi times the radius times the height, which is 24. So just going through and multiplying these out, 6 squared is 36. And then 2 times 6 times 24 would end up giving us 288 pi. Then if I do 2 times 36, that's 72 pi. And then we add 288 pi. So if you add those together, it is 360 pi. And then the units on this are area, so that would be inches squared. So again, this is the exact. Plugging this into your calculator, you would see this is about 1130.97 inches squared. That would be the approximate, okay? Moving on to the next example, this is going to be a rectangular solid, aka a box. So we've got our 3 sides, which are 12, 6, and 3. Honestly, it makes 0 difference which one you call the length, the width, and the height. The volume on this is always the nicest. It's just multiply the 3. So one side is 12, one side is 6, one side is 3. So if you do 12 times 6 times 3, you get 216. It's a volume, so this would be the units cubed. And in this case, those units are feet. So this is our volume exactly. Moving on to the surface area, that's just a bunch of different rectangles. So starting with the top and bottom of the box, you have 2 sides that have area, length times width. Then moving on to the left and right of the box, those are 2 sides with area, width times h. Then the front and back of the box are 2 sides with area, length times h. So again, really doesn't matter which you put in, but just kind of staying in this order, I like to do the top and bottom first. And those side lengths are 12 and 6. So we have 2 sides with area 12 times 6. Then moving on to the side, 2 areas that have sides 6 and 3. So we do 2 times 6 times 3. Then we've got the front and back of the box, which has lengths 12 and 3. So we do 2 times 12 times 3. So if I multiply these out, 2 times 12 times 6 will give you 144. 2 times 6 times 3 will give you 36. And 2 times 12 times 3 will give you 72. So adding these all together gives you 252, and it's an area, so that unit of measure is squared. So my surface area is 252 feet squared. So now we're going to talk about a more general type of figure. So it's not some of the clear-cut shapes, but these are more defined for things you see in everyday life. So the first thing we're going to talk about are polyhedrons. So a polyhedron is a closed surface formed by the union of polygon regions. Basically meaning you take a bunch of polygons and then you connect them all together somehow. So really, a lot of the examples we just did are polyhedrons. That rectangular solid, a polyhedron. Every single side was a rectangle. Cylinder, not a polyhedron because it's got that circle, so it's got those arches for edges. So here, we still have a lot of the same terminology. The sharp points are still vertices, or a vertex for singular. Now these pieces here, which I've been calling the sides so far, have a better name for polyhedrons. These are called faces. And then the last definition is one of these sharp lines where the two faces meet are called edges. So there's actually a really nice connection between these different things. You can look it up if you want, called Euler's formula. But there's, in order for a polyhedron to actually be formed, there has to be a distinct connection between the number of edges, number of faces, and number of vertices. But the main idea here is you can now take different shapes and combine them. So if you look at this example, all of these different sides are going to be triangles. And same thing here, you've got a bunch of triangles forming this other region. This one has a trapezoid for the top and bottom, and then all of the sides are just either rectangles or quadrilaterals. Okay? So there's no kind of set rhyme or reason for polyhedrons, but they form these nice geometric shapes. If we want to get something more specific, what we're going to talk about finding the volumes of are prisms and pyramids. So a prism is a very specific polyhedron whose bases, which are the top and bottom, are exactly the same shape. So they're congruent polygons. And the sides are always going to be quadrilaterals. They can be shifted at angles or something like that, but basically the sides are either going to be rectangles, squares, or parallelograms, because they all end up having basically the same area formulas. So to give you some examples of this, if you look at this shape, the bases here are going to be two triangles. So the top and bottom are the base. This one's just called the top base. And this one's called the bottom base. We know how to find the area of each of these shapes because they're triangles. And then really to actually find the overall volume of the prism, we just have a height, which is going to be the distance between the top and bottom. And then likewise, if I look at this figure here, the top base is going to be a trapezoid, and the bottom base is exactly the same. Okay? So when you go to find the volume of a prism, the volume is based on two things. It's based on the area of the base, which we're going to dictate with a capital B, and then the height. Okay? So going to this figure over here, this has area, which is based on the triangle, and then we've got the height. So this is why I went through those formulas very precisely as the area of the base times the height, because that's exactly where this prism formula comes from. So this is where capital B is the area of the base and H is still representing the height. So let's try an example of this one. We're going to determine the volume of this particular figure. So if I look at this, it's kind of shifted, but I notice that I've got a triangle here, which is a right triangle. And then this one is exactly the same. So my base in this case is a right triangle. So it's really kind of like a nice wedge, a wedge cheese, a doorstop, whatever you want to call it. But if you look at the other pieces of this top part is a quadrilateral. The back part here, quadrilateral. And then the bottom, also a quadrilateral. So this is exactly a prism. So I want to go ahead and I need to figure out two things. What's the area of the base and what's the height? Now realistically, the height is just the distance between the top and the bottom. So my height in this case is going to be exactly 18 meters. Now my base is a right triangle. So that formula is 1/2 the base times the height. Now it's kind of redundant using the words base and height here, but basically the two sides that make that right angle. So in this case, my area is going to be 1/2 times 10 times 12. So multiplying that out, well, 1/2 times 10 is 5, and then 5 times 12 is going to give us 60. And then we can be really precise, the area of the base is 60 meters squared. So now that I know this area, all I need to do is multiply it by the height to get the volume of my wedge. So our volume is the area of the base times the height. We figured out that was 60, and the height is the distance between the top and bottom base, which is 18. So if I multiply those out, I get 1,080, and then my units on this are going to be cubed because it's a volume, so it's meters cubed, okay? So every single one of your three-dimensional prisms will follow the same kind of pattern. You might need to revert back to some of those area formulas, but it is the area of the base times the height. The second special type of polyhedron that we're going to talk about is a pyramid. And you can think of this exactly like what we call the pyramids in Egypt. It's going to be where you have some kind of base as a bottom, but it's going to come to a sharp point. So there's no longer a top and bottom, there's a single base. So a pyramid is a special polyhedron, but they only have a single base and they come to a sharp point. So in this case, my base here would be a parallelogram. And then I still have some height to this pyramid, but all of my sides end up connecting to the corners of my base. Here, my base is a trapezoid, and then I've got that height to give me the sharp point, and then I figure out all of my other sides here by connecting it to the vertices of my base. So you can see all of the sides of this end up being triangles instead of quadrilaterals. Same thing here, my base is triangular. I have a height, which is the distance from that base to that sharp point, and then I form my shape by going and connecting that sharp point to every single vertex on the bottom. So kind of like when we were dealing with the cone, you had that third involved because it cuts it into 3 distinct pieces. It's the same idea here. So if I were to instead have that full prism like this, I would have the area of the base times the height. But because I'm taking only 1/3 of that, the volume really takes the volume of the prism and just multiplies it by 1/3. So you still need to figure out what is the area of the base, what is the height, but then you just multiply it by 1/3. So really what we have left is just a few more examples of this. We'll try to do some more complicated shapes here, but we're going to start by determining the volume of the shaded region, because this is going to give us a little bit of practice with different types of volumes. So what we ultimately have here is we've got this cube, or this rectangular solid, because technically they don't have all of the same values here. And what we've done is we basically hollowed out a pyramid from it. So if I want to find the volume of the shaded region, so I'm going to use this, which is subscripts, the volume of the shaded region is going to be the volume of the box, which is my bigger shape, minus the volume of my pyramid. Okay. So So if I can find each of these things, I just go ahead and subtract it. So starting with the box, that one's definitely much easier because all I do is multiply those three sides. The area of the base is a square, and then I go ahead and times it by the height. So we have 3 times 3 times 4, which ends up giving us 36. And the units on this would be feet cubed. Okay. Now I need to figure out the volume of the pyramid. Well, this one's a little bit more annoying, but just in general, a pyramid is 1/3 the area of the base times the height. So going through each of these things, let's just go ahead and put these in parentheses. The height's a little bit easier. This goes to the very top of the box. So this distance here is exactly our height. So the height at the end will be 4. When I look at the area of the base, that's going to be a square. So in this case, my area of the base would be 3 times 3. Okay. Then I really just need to multiply these out. This is 1/3 times 9 times 4. Well, 1/3 times 9 is 3, and 3 times 4 gives us 12. And then again, same units, feet cubed. So I have the 2 different volumes I need. That tells me the volume of my shaded region is the volume of the box minus the volume of the pyramid. So ultimately, the volume of the shaded region is 24 feet cubed. Okay. So I got one more example. This would also be one, just the box, not hard to find surface area for. Definitely don't expect you to be able to find surface area for a pyramid or something like that. We're going to try one more example, didn't need all that space in between, where we're going to find the volume of this object. Technically, this is one you could also find the surface area for. If you need help with that, just let me know. But for time's sake, I'm just going to find the volume because that's the more important piece. So they give us a ton of different things going on here, but you can basically assume, because all of those sides are quadrilaterals, that this indeed is going to be a prism. So if I want to find the volume, I need the area of the base times the height. Okay. The height I do know, because that's the distance between these two. And I'll go ahead and kind of go sketch this in so you can see that this is indeed a prism. But this solid would look like this. So in that case, my height is the distance between these, basically a barn shape. This height would be 35 inches. Okay. So I know this, but I need to more precisely figure out what is the area of the base. So going through that, I'm going to go ahead and bring this shape over here to make life a little bit easier. So we've got our barn going on. Might not be perfect, but that's okay. So they tell us this bottom has a right corner here. This is 29 inches. This side here is 13 inches. This side and this side are exactly the same as over here. These are both 13 inches as well. Okay. Then we're told that this piece here is 5 inches. So going ahead and kind of connecting those, that's a straight line. Again, you can see didn't draw it great because this should be hitting at a right angle. This is 5 inches. This side should be exactly the same as this one. So just kind of filling that in because we're going to need it. This is 29 inches. They don't give us this top part here. However, we do know it back here. So this top also is going to be 5 inches. And then this piece here, just for completeness, is the same as this one. This is also 13 inches. So you can see definitely not drawn to scale, but that's okay. So if I want to figure out the area of this, I really have two different shapes going on. I've got this top part, which is a trapezoid, and then I've got this bottom part, which is going to be a rectangle. So the area of my base is going to be the area of the rectangle plus the area of the trapezoid. So the rectangle's much easier. In this case, it's got two sides, 29 and 13. So we go ahead and just multiply the two. So if you do that, 13 times 29 will give you 377. Now the area of a trapezoid, that's a little bit more annoying, but just to put that over here so we remember, the area of a trapezoid is going to essentially be the height times the base, but the problem is you have two bases, so you need to find the average of them. Add them together, and then divide by 2. So the area of my trapezoid is 1/2. The height in this case is 5. Base 1, doesn't matter which one you pick, but the two are 29 and 5. So we do 29 plus 5. So going through and simplifying this is 1/2 times 5. 29 plus 5 will give you 34. And then from there, that's something you can actually just plug into your calculator, but 1/2 times 34 would give you 17. 17 times 5 will end up giving you 85, not 7. Okay. Then adding these two together gives me 462. And then this is an area, so this unit is inches squared. So I have the area of the base of my prism. So all I need to do is multiply that by the height. So my volume is going to be 462. And just to show you the units work out, the area of the base is in inches squared. The height is 35 inches. So going through and multiplying those gives us 16,170. And the inches times inches gives us inches cubed. Okay? So that is the volume of this object. Just to kind of show you, because again, you can find the surface area of this shape. It's really not too bad from this point. What you can do is you need to find the area of each of these sides. Well, you already found the area of the front and back. Both of those are 462. Then you would just need to figure out what are the areas of all the sides, which are just rectangles. So you have one side here, which is a rectangle with 35 times 13. And that's really exactly the same as the rectangle in the back. Then you've got one rectangle here, which has sides 35 and 13. So you multiply that. And it's the same as the other side over here. Then you've got this top rectangle, which is 5 times 35. And then you've got the bottom rectangle, which is 29 times 35. So really solving for this volume did a bulk of the work, because the hardest part is what is that funky shape, which is the front and back of the barn. So you would go ahead, just add all of those up to get your surface area. Okay. So give yourself lots of time to go through these. Be extra careful when you're plugging it into your calculator. Pay attention to the units. Make sure they're all the same before you start multiplying them. Because if by chance they put one of those units in feet instead of inches, you might have to do some conversions to be able to actually find the area or volume.